So let's look more at the difference between these things. If I just evaluate x in an empty namespace, then I will get x as undefined, right? On the other hand, if I do quote x, that has nothing to do with any possible definition of x. It just makes the symbol x, right? If I do hash quote x, then it's more like quote x, right? But it produces a syntax object. And you can see in the printout what this means is that it is a syntax object. That's the hash angle syntax colon part. You can see that a syntax object has some numbers associated with it. These are source locations. It was the first, this x right here was on the first line, and it was 4 characters over from the beginning of this editor region. Okay? And then it shows that the content inside of the syntax object has an x in there somewhere. Similarly, if I do +1, 2, in this case the open parenthesis is an application parenthesis. That's an application of plus to 1 and 2, and so in evaluating it gives me 3. If I have quote +1, 2, then that's making an S expression, which turns out to be a list with a symbol and 2 numbers inside of it. If I do hash quote +1, 2, then it's more like quote 1, 2, quote +1, 2, but it produces a syntax object, which has its source location, and it has the plus and 1 and 2 inside of it. Okay. And in addition to the source location, it also has information about the bindings that are in the environment of plus, and we'll see more about that in a minute. First, though, I'll point out that if I have a syntax object, like quote x, then I might want to get the symbol x out of that syntax object. And there's a function syntax e which will do that. So syntax e unwraps the lexical and the source location information associated with the syntax object and pulls out some kind of S expression that's immediately inside there. If I have just a 1 as a syntax object, when I do syntax E on that, then I get the S expression 1 out, which is the same as the number 1. If I have a +1, 2, and I do syntax E on that, so +1, 2 is a syntax object, syntax E on that, then what you get back in the case of a list syntax object is a list of syntax objects. So I got 3 syntax objects back, 1 for the plus, 1 for the 1, and another one that's kind of scrolled off here for the 2. So that's how I can take a syntax object apart. You can also put a syntax object back together. Like suppose I have the symbol x and I want to make it the syntax object x. Then the way we do that is a function called datum to syntax. And if I just say datum to syntax, that's not quite enough information, because where do we get the source location, or more importantly, the lexical context for that symbol x, to say what x binding should be. So datum to syntax actually takes an extra argument. First, it takes a syntax object, and that syntax object's information is going to be transferred to the x, at least the lexical part. It turns out that there was no, the source location wasn't carried over, and we'll talk more about that later. But you can see there's an x inside there wrapped now as a syntax object.